everyone. Today I'm going to be showing you how to determine the coefficient of static friction of an object inclined at an angle to the horizontal. So I'm going to be drawing an inclined plane showing an object that is inclined and at a specific angle to the what? To the horizontal. Now let's assume we have a plane like this, right? Let's say the plane is like this. Please don't mind my drawing. Let's say um this particular plane is inclined to the horizontal at an angle theta. Are you getting? Now let's say we have an object on this plane. Let's say this object is here. Are you getting it? Now, for us to know the coefficient of static friction of this particular body, then we have to consider three cases. There are three forces acting on this body, and somebody may be asking, why are there three forces? Then we have a force that is parallel to this plane to slide this body downward. So I use F subscript P in that case. Then we also have a force that acts through the center of this body downward here. Now I call this not I call it, it is often called what? The force of what? Of gravity. Now there's another force that acts at right angle to this body, to the plane, to this to the surface of this plane, and that force is known as what? The normal what? The normal force. So in this case I use what? F subscript what? Small n here. So this is the normal. So these are the three forces that are put into what? Into consideration. Don't forget the normal force is acting at 90 degree to this what? To this plane, right? Now how do we now resolve what? This particular body? Then we are going to be applying some mathematics here. Now some knowledge of geometry. Now if you look at this, this is what? This is theta. Now of course this one will be what? This is 90 because the gravity to the surface is what? Inclined at what? At 90 degree. So what will be this angle? This angle will actually be what? 90 minus theta. Please don't mind me, just let's manage it. This is 90 minus theta, right? Now if this is 90 minus theta, how do we get 90? Because the sum, this is a triangle on its own, and the sum of the total angle in a triangle actually is what? 180 degree. Are you getting? So this, or if this is 90, this is theta, this will be what? 90 what? Minus theta, and sum of everything will give us what? 180 degree. Now if this is theta, actually what we are actually interested in is a triangle from this side, because this is the triangle that we're going to be using to resolve this force. Now this, before I proceed, this parallel force here is the same thing as what we have here. We can reproduce it here. Are you getting? So if we reproduce it, this is what? Another what? 90 degree. Of course, if this is 90 degree, right? Now what will this be? How do we know? Then let's do it. Now after doing this, you know, this is another small triangle here. So if this is 90 minus theta, this one here will also be what? 90 minus theta. I may not want to write it because of space. If this is 90 minus theta, this small one will be what? This one will be what? 90 degree, right? Right? If this is 90 minus theta, this is 90 because it is inclined at 90 degree to this particular what? Surface. So this one will be what? This one will be theta. So if this is theta, you know that this is another long bigger triangle. So if this is theta, this one will be what? 90, right? 90 minus what? Theta. So this is 90 minus theta, this is 90, and the other one up there is what? Theta. So let me just squeeze it here. Let me say this is theta. Right? Now having understood this, just get the explanation. Now I can actually label these three. I can call this A, because I have to take out this triangle. I call this what? B, and I call this what? C. Right? Now we can say, let me now bring out the triangle. We can say from triangle what? A what? B C. So if I reproduce that particular triangle, what am I going to have? I'm going to have something that look like this. something that look like this, right? I have something that look like this. Sorry, something that look like this, right? Now if you look at this, so I want to do it, this will represent what? My force of what? Gravity. Now this will be my what? Force what? Parallel. Don't forget I told you that this line is FP, this same line is this one, so let me just put it here simply, right? So this will now be what? F subscript what? N. That's the normal what? Normal force. So in this case we have this to be what? Of course you already know 90 minus what? Theta. This one is what? Already 90. Of course this is what? Our what? Our theta, right? So this is force of gravity. Actually everything is gotten from this triangle. Please, if you don't understand, I can reproduce another video that will expatiate it, but I think this explanation should be enough. Now something must be noted: all components will be resolved with respect to the force of gravity. What am I saying? The force of gravity is our reference what? Our reference force here. It implies that if you are looking for parallel force, it will be parallel force with respect to the force of gravity. If you are looking for what? Normal force, to be normal force with respect to the what? Force of gravity. And what is our angle of focus, or our reference, our reference angle? You know that our reference angle from this inclined plane is theta, but after we did all this resolution, theta actually find itself there. I hope you understand how we got it, because if this is theta 90 minus theta, we have 90 minus theta here, opposite angle. This is another what? 90. So this is theta. So this theta is found itself here. So when we bring out this triangle, we have it what? Here. So this is our what? Reference what? Angle. So we are not going to be solving it in what? In cases. So in this case we are going to start with case 1. So how does case 1 looks like? Let me just scroll up a bit. Case 1. So in this case, case 1, I think I will have to call this video after case 1. We look case 2, case 3, then, so that it won't be too long. Now case 1, we say the perpendicular, we are going to be doing the what? The perpendicular, or we call it normal. Anything that is perpendicular is normal, is forming 90-degree, right? Normal component, right? Normal component of what? The what? The force, right? Which is given to be F subscript N. So if we want to find the what? Perpendicular or normal component of the force, then that one will now be what? You know, I told you that we are doing it with respect to the what? To the force of what? Gravity. We are doing it with respect to Fg. So that will now be what? Fn and what? Fg, right? So it will now be what? We can say that will be what? This implies what? F what? Fn and what? And F subscript G. So if theta is our what? Reference angle, and we are doing Fn and F, this theta, so this place will actually be what? Opposite. If theta is our reference, then if this is opposite, of course this is what? Hypotenuse, because it's the one side facing the right angle, or the longest side. So this is the what? Hypotenuse, and this is the what? Adjacent, right? So in this case we are doing Fn and Fg, so this will now be adjacent over what? Over hypotenuse. Don't forget your trigonometry. Your trigonometry say car is the same thing as what? Cos theta, which is equal to what? Adjacent over what? Over hypotenuse. So that would be, so what's our adjacent? Our adjacent is what? F subscript N over what is our hypotenuse? F subscript what? G. So this implies that we can say that what? Cos theta is equal to what? F subscript N over what? F subscript what? G. But what we are looking for is what? Force perpendicular, that is Fn, that's the normal component. So this implies that what? F subscript N is equal to what? Cos theta times what? F subscript G. So now we can say, let me scroll up a bit. So we can say this implies that F subscript N is equal to what? F what? Subscript G cos what? Theta. Am I on point? Now don't forget that F subscript G is the same thing as weight, which is equal to what? Mass times what? Acceleration due to gravity. So therefore we can say F subscript N is equal to what? Mg, right? cos what theta. So let me call this equation 1. In some cases they use r in place of f subscript n, so we can say r is equal to what, f subscript n, which is equal to what, mg what cos what theta. So that is the what normal component of the what, of the particular what force. So in the next video we look at the next component, which is the what, the horizontal component. Of course you can easily predict that from what we have here. I hope this video helped. Subscribe and comment